assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Okay, in this problem we have we want to find the net electric potential or voltage at the origin, and due to this, we have a circular arc here of distributed charge, and that the total charge here is 7.21 picocoulombs. And again, how it's distributed, it turns out to be irrelevant, and whether it could actually just be a point charge on anywhere here. Well, at least as concerned with this point here. Um, Obviously, we're looking at different points. It would matter where it was, but because this point is the same distance from all of any part of this ring, then we could have a point charge anywhere here, and the voltage here would be the same. Then we also have a point charge down here, a distance r, so that would be kind of part of the, if it were continued on the ring. And then we have another charge over here, that's 2r from this point here, and at an angle of 20 degrees, but it turns out that obviously that's going to be irrelevant. It's just the distance that the charge is from. So we have this point charge here. Now this point charge here is positive. In fact, I should have made that red. If one can stay consistent, that this is positive, and then this is a negative charge here. Now, let's see here. We can figure out that, we can either figure out the potential here from integrating, but in the end, we're just going to integrate and just sum up the charges because the distance is the same from any charge on this circle to this point here. So that's just, in the end, it's just going to be k. So I've used k, again, equals 1 over 4 pi epsilon naught, times the total charge on here, divided by the distance, or the radius of this circle. So again, at this point anyway, it doesn't matter where how the charge is distributed on here. Obviously, at other points, it would make a difference. So say we're here, it would make a very big difference if the point charge were here or if it were here. But at this point, it doesn't matter because these charges are all equal distance from that point. And let's see here, too. This is a point charge anyway, so we have just our expression here, and we have 2r is the distance. And then from here, we have the distance is r. So the total potential is just the sum of all of these, the potential from each of these pieces. So we can sum all that up. And we get that, let's see here, we know that this is, let's see here, we wind up with 1q1 plus 4 minus 2. Why do I have, I think I just missed a factor of 3 here. Oh, no. We have again this half here, so this would be q1 this, and if we plugged in 4q1 here, so we get 2, and then we get so we get 1 plus 2 minus 2, and that gives us this. It ends up being kq1 over r. Okay, just using these expressions here. I'm just, doing a little algebra. And plugging in our values, we wind up with what looks about 32 millivolts, or 32.4 millivolts is the voltage, or the electric potential right here at this point here.